and let's solve LEETCODE question 35, search insert position. So given a sorted array of distinct integers and a target value here, and you can see this is number of array here, and return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O log n runtime complexity. And for example, if the nums are 1, 3, 5, 6 and the target is 5, in this case you want to return the 5's index number, which is 0, 1, 2. So the output is 2 in this example. And the second example, if the target is 2, you want to find a 2 in here, and then there's no 2 here, right? So if there's no 2 here, you want to return the index where it would be if it were inserted in order. So if you want to insert 2 here, you want to insert in between 1 and 3, right? So the index will be 0 and 1. So that's why the output is here, because it's index 1. And in this example, it wants you to find target 7, and target 7 obviously is not here. And you can see 0, 1, 2, 3, 4. You want to insert in the 4th position, and that's why the output is 4. And here are some constraints here. And here are the companies asked this question in the last 6 months. And a good hint to write this algorithm is that you must write an algorithm with O log n runtime complexity. Does it ring a bell to you? If so, you probably think about the binary search. That's actually the correct answer, and that's the most efficient way to solve this problem. So for binary search, what we want to do is we want to have 2 pointer for binary search. We want to start the left pointer from here and the right pointer on the most right number, and then we want to find a mid number, for example here. And once we find a mid number, we gonna calculate while we want to use a while loop for the binary search. And if a while, the loop will continue runs while L is smaller or equal than the right pointer in that case, and then we calculate the mid pointer. And if the target is smaller than so if the target is equal to the midpoint, that the problem is solved already, right? If the midpoint is 5 and the target is 5, and then we just return the midpoint index, right? The problem is solved. And if, let's say, the midpoint is 3, and if the target that we're looking for is bigger than the midpoint, that means that we need to search on the right side of the array. And in that case, what we need to do is just move the left pointer to mid plus 1, which is to here, right? If this is the midpoint, if the target that we're looking for is smaller than this, let's use this example. If the target is 2 is smaller than the midpoint, then we want to look on the left side of the array. In that case, we want to shift the right pointer to mid minus 1, basically to this position, right? When we shift to this position, this is for the case that the target number exists in the array is pretty straightforward. We just need to think about if the target number is not in the array, what do we do? If this is the midpoint, right? And then if the target is not in the array, what we wanted to do is shift the right pointer to the mid minus 1. So the left pointer is here, right pointer is also in the 0 position, right? And then when we go through the while loop, we want to calculate a new midpoint for the left and right point. Both are located in the index 0 situation. Then when we calculate the new midpoint, is actually the new midpoint is let's say it's 1, right? And then the target is 2. That means we need to look for in the right side of the array. So then we need to shift the left pointer to mid plus 1, and so that the left pointer will be at index 1. So that's why essentially, if the target does not exist here, the index we want to return is actually the left side pointer. And that's how we can solve this problem. And I'm going to show you how to do this in code. So we want to have one left pointer. I'm just going to start at index 0 here. And the right pointer, I'm going to do length of nums. Basically, the length of the array minus 1, that will be at index 0, 1, 2, 3, 3 here, right? So the while loop will be while the left pointer is smaller or equal to the right pointer, then the loop will continue to go on. And when we when we get out of the when this while loop does not meet, when we get out of the while loop, what we wanted to do is essentially return the left side of the left pointer's index, which is the scenario when the target does not exist in the array. So that will be that case. So if while the L is smaller than the right side of the pointer, what are we going to do? We're going to calculate the midpoint. Midpoint is left pointer plus right pointer. And in Python, you want to do, it's not really divided by 2, but it's like getting the integer part when you do the division. So if you're not familiar, you can feel free to look it up, but this is how you do it. Basically, if you have a left pointer here, right pointer here, and then the midpoint for this one will be at the 3 position. So if the target that we're looking for is equals to nums m that we just calculated, then the problem is solved already. We just want to return the m index. That's the answer already, right? If the rest, you just do binary search. If the target is bigger than nums m, if it's bigger than the midpoint, that means that the number is bigger than the middle. Then we need to start looking on the right side of the array. In that case, we want to move the left side of pointer to mid plus 1 to continue the search, right? And the else situation will be if the target is smaller than the mid number, it will means that we're going to have to search on the left side of the array. When we search on the left side of the array, then we want to move the right side of pointer to midpoint minus 1. That's basically what it is. And then in the end, when we get out of the while loop, we want to return the left pointer, including the scenario that when target does not exist in the array. That's what we want to return. And that should be it. And it also meets the O log n runtime complexity. And let's run the code. Yep, it's accepted. And I hope this is helpful, and please like my video and subscribe to my channel, and I'll see you soon with more LeetCode question. Bye bye.